morning everyone. My name is Mrudula, working as Assistant Professor in the Department of Electrical and Electronics Engineering at MLR Institute of Technology, Hyderabad. Today I am going to discuss a topic about transformer selection. These are the different key points which I am going to discuss today, like introduction to the transformer, what are the different types of transformer and key factors for selecting it, the load requirements, the voltage considerations, transformer impedance and regulation, environmental as well as installation considerations, efficiency and losses, and cost versus the performance. The first one is introduction to the transformer. What is a transformer? It is an electrical device which is used to change the voltage. The voltage that is alternating current, AC voltage. Transformer works for only AC voltage. It is used for changing the voltage. Works on the principle of electromagnetic induction. What are the applications of transformer? The power transformer and distribution, electrical isolation between the circuits, and voltage regulation in various industries. That means the power transmission and distribution, these are used in transmission as well as in distribution lines. Which are being connected to generating stations. So the transmission and distribution lines which are being connected to generating stations, to this particular transmission lines we will be connecting this power transformers. Power transformers where the capacity is very high. The second application is electrical isolation between the circuits. That means this is the symbol of a transformer where this is your primary and this is your secondary. The primary and secondary are not electrically connected. They are magnetically connected by using the principle of electromagnetic induction. So, as the primary and secondary are not electrically connected, the transformer can also be used for electrical isolation between the primary as well as secondary. That means the primary and secondary are being electrically isolated. So for isolation purpose also we can use the transformer. The next one is voltage regulation in various industries. Voltage regulation means you can increase the voltage or reduce the voltage based on the load. So, based on the load voltage, we can increase or decrease the voltage. That is the third category, voltage regulation. The second one is used for isolation purpose. The first one is used for connecting to the generating stations. That is mostly the transmission as well as distribution, which is connected to generating stations as well as different substations. So these are the three different types of applications of a transformer. What are the different types of transformer? First one is stepped up transformer. Step up transformer means which increases the voltage and decreases the current, and which is used in power transmission. That means the generating station, this is your generating station. Generating station is connected to a transformer. This is a step up transformer. So this particular transformer increases the voltage from the generating station and then it is connected to a transmission line. Here this step up transformer, it increases the voltage and reduces the current as the power is same. As the power is same on the primary as well as secondary side, as the voltage increases, the current reduces for the step up transformer. So, the second one is step down transformer. Step down transformer means it decreases the voltage and increases the current. As I said, the power, that is V into I, the power is constant. So, as the voltage increases, current reduces. Or else if the voltage reduces, the current increases. So here in the step up transformer, voltage increases and current reduces. In step down transformer, voltage reduces but current increases in order to maintain a constant power. And it is used in consumer applications. That is, from this transmission line, it is given to the transmission line is connected to a substation. In this substation, again one more transformer is being used. This transformer is nothing but a step down transformer which is connected to distribution line. This distribution line is again connected to different consumers, and here also we will be using a transformer, that is step down transformer. So this step down transformer can be used for consumer applications. Next one is isolation transformer. This isolation transformer, it is provided for electrical isolation without changing the voltage. That means the primary side as well as the secondary side, the voltage is same. Here it is V1, here it is V2. If V1 is equal to V2 and this there is no difference in the voltage, but this is only used for the isolation purposes. It is one kind of protection device for isolating. That is called as isolation transformer. It is used for safety in sensitive equipments. For sensitive equipments, we will be using this isolation transformer without changing the voltage or current. The voltage is same, current is same, as well as the power is also same and frequency is also same in isolation transformer. The next one is auto transformer. The single winding serves for both primary as well as secondary. In auto transformer, actually in normal transformer, we will be having the primary as well as secondary. We will be having primary and secondary and two different windings. First one and second one, two different windings are being used for primary and secondary. But in auto transformer, we will be using the same windings. We will be using the same windings for primary as well as secondary also. For primary as well as secondary, we will be using the same windings in case of auto transformer. So, it is efficient for voltage conversion in small power applications. For small power applications, we can use this auto transformer, and we can use only the single windings for both primary as well as secondary. So by using the single winding, the overall cost of the overall cost or else the initial cost of the transformer is being reduced. So these are the different types of transformers. Next one, key factors for transformer selection. What are the key factors to be considered? The first one is power rating. So based on the power rating, the transformer power rating is kVA or MVA. That means, as I said, the transformer works on the AC voltage, and AC voltage or AC power, and the AC power is being measured by kVA, that is kilo volt ampere. kVA, kilovolt ampere, or MVA, that is mega volt ampere. This is 10 power 6, this is 10 power 3. So based on the kVA or MVA rating, we can call it as power rating of a particular transformer. Second one is voltage rating. Voltage rating means, as I said, you will be having a primary as well as a secondary. So primary side one voltage will be there, secondary side one more voltage will be there. So based on the voltage levels of primary voltage as well as secondary voltage, we will decide a particular transformer. So the second one is voltage ratings on primary as well as secondary. The third one is frequency. The transformer must match the operating frequency, that is 50 Hz or 60 Hz. If the transformer is connected to the other frequency, that is 40 or 30 Hz, the transformer will not work. The transformer will work only for two frequencies, that is either 50 or 60. The next one is efficiency. The transformer efficiency impacts the operational cost and performance also. Okay. The transformer efficiency impacts on the operation cost as well as the performance also. Next one is load characteristics. Determine if the load is continuous. If the load is continuous, intermittent or fluctuating. If the load is continuous, intermittent or fluctuating, so based on the load characteristics also, the transformer differs. So transformer is selected based on its power rating, based on its voltage rating, based on the frequency which is connected, based on the efficiency of and the performance cost, and based on the load characteristics. What are the load requirements? The constant versus variable load. That means based on the time period as well as the load. The load may be a fixed load or else it may be a variable load. So constant load, select a transformer rated for continuous duty. And variable load, requires a transformer with sufficient capacity to handle the peak loads also. So in constant load, the load will be applied continuously without any break. In variable load, the load may increase or decrease with minimum value, or again it may increase. So the voltage level will be very high or zero or minimum based on the time. That is variable load. So it requires a transformer with sufficient capacity to handle the peak loads also. So for variable load, the transformer should be able to handle the peak loads also. Next one is current. So consider the current characteristics for proper sizing. The proper size of a transformer. The size of a transformer is also very important. So the size of a transformer depends upon the current characteristics. Next one is voltage considerations. The primary voltage, secondary voltage as well as tap settings. Primary voltage. The input voltage from the power source, or example it is grid, is called as a primary voltage. As I said, this is the diagram of a transformer where this particular voltage is the primary voltage and this is the secondary voltage. And this voltage is connected to the grid. This voltage is connected to the consumer or the load. Consumer or the load. And here the voltage may be 11 kilovolts or 33 kilovolts or 660 volts. Here the voltage may be around 240 volts or 430 volts, like that. Next one is tap settings. Selected tap settings allow for voltage adjustments. Like if you take the example of auto transformer, where the same winding is used for primary as well as secondary. So in this, the tap settings, this may be adjusted to here or here or here. So these tap settings should be done properly in order to adjust the voltage, in order to adjust the secondary voltage. Transformer impedance and regulation. Transformer impedance, it affects the short circuit current as well as voltage drop under load. It affects the short circuit current as well as voltage drop under load. Next one is voltage regulation. It indicates the ability of a transformer, to maintain output voltage under varying load conditions. It has to maintain the output voltage, that is secondary voltage. Output voltage or secondary voltage under varying load conditions also. Environmental and installation considerations. What are the environmental and installation considerations? First one is ambient temperature. That means the transformer should be rated for operating temperature range. There should be a temperature range for a particular transformer. Cooling method, dry type, oil filled or air cooled or water cooled transformers. That means this is a particular transformer which is placed in a box, and this particular box may be a dry type, or it may be an oil filled, or it may be an air cooled or water cooled. Means there is a particular temperature limit for a particular transformer. So based on the temperature limit, the transformer works. In order to reduce the temperature, means if the transformer is working for longer duration, the transformer may get heated, and to reduce the particular heat of a transformer, we may use this dry type, oil filled, air cooled, all these techniques for reducing the temperature of a transformer, or in order to maintain the temperature of a transformer. Next one is size and weight. The transformer is available at different sizes with different weights based on the voltage levels. Next one is safety and protection. Ensure proper insulation as well as grounding. That is, the transformer should be properly grounded in order to ensure proper protection. So consider overcurrent as well as short circuit protection also. The overcurrent and short circuit current values also should be considered, and based on that the transformer should be selected. Next one is efficiency and losses. There are different types of losses in a transformer. First one is core loss. Core loss are also called as constant losses, which are occurring in a transformer. They don't vary, so that is why they are called as constant losses. Second one is copper loss. Copper loss are nothing but the variable losses depending upon the current passing through the windings. So based on the current passing through the windings, the copper losses vary. So that is why they are called as variable losses. The third one is load losses. Load losses are proportional to the square of the current, and efficiency will be output by input power, that is P out by P in into 100. P in is nothing but P out plus losses. These losses are constant plus variable losses. Constant as well as variable losses. Standards and regulation. What are the different standards and regulation? They should follow the IEEE, NEC as well as IEC standards. Cost versus performance. The initial cost, it depends upon the transformer type, size as well as quality. Based on the type, size and quality, the initial cost depends. And operating cost, considering the long-term energy efficiency. Based on the long-term efficiency, the operating cost will be there. And life cycle cost means regular maintenance should be done, repair works should be done, and replacement cost also comes under the life cycle cost. So all these costs are included in a transformer. That is initial cost, its operating cost as well as maintenance cost. Case studies and example. Industrial transformer selection. See, for choosing a transformer in large industrial motor. For residential purposes, sizing of a transformer for residential distribution network. That means the transformer should have higher voltage ratings for industries when compared to the residential voltages. So the cost as well as size is more in industrial application when compared to the residential application. Transformer selection involves the consideration of power ratings, voltage ratings, and load characteristics and environmental factors. So transformer should be selected based on the power, voltage, load as well as the environmental conditions also. Choosing the right transformer for proper selection ensures efficient, reliable as well as cost effective operation also. So the cost and the reliability also should be considered for selecting a transformer. So this is all about a transformer. In next class, I would like to tell about industrial loads. Thank you.